Okay, YouTube, this is my second video in which we are solving trig equations, and in this video we're going to highlight some basic steps that you take when solving these things. And you notice here that our equation that we're trying to solve is sine of an angle plus the square root of 2 is equal to negative sine of an angle. So let's go ahead and start by acknowledging some things that are pretty common here. Starting with this, when you want to solve for a variable, of course, which in this case is an angle that would make this equation true, we want to isolate that thing. So if you were to have sines on both sides, the angle on both sides, what we want to do is we would want to isolate them. So get all the sines on one side. In other words, one really appropriate thing to do is this. We say set equal to 0, equal to 0. And so this is probably the first thing we often try to do. It's not always a necessity, but in this particular case, it is what I want to do. So if we have the sine of an angle plus the square root of 2 is equal to negative the sine of this angle, the very first thing I'm going to do is I'm going to take this sine right here, I'm going to pop it over to this side. So essentially we're going to add the sine of that angle to both sides, and we can just combine like terms here. This is just algebra, but we have two sines of this angle plus the square root of 2 equaling 0. So if I want to isolate, especially the x, but isolate the trig function first, that means that our root 2 needs to go and our 2 in front here needs to go. So we'll subtract the square root of 2 from both sides. We end up with this. We get 2 times the sine of this angle is equal to negative the square root of 2. And now we'll just take both sides, we'll divide it by 2. So we get just the sine of x now, or the angle, is equal to negative root 2 over 2. So now that we have isolated this trig function, what we want to do is we want to undo this trig function by taking the inverse trig function of both sides. We're not multiplying by an inverse trig function, we're taking the inverse trig function of it. So it annoys me when people write this over here because it's like sine inverse of what? No, we are taking the sine inverse of both sides. So once we get this, we have that this cancels out, and one of the most important things that you can write on your paper if you are doing these is this, because what you have done is you have technically listed the answer right here. We say this angle is the angle that when you took the sine of it, you got negative square root of 2 over 2. Okay. So the very first thing that I'm going to recommend you do once you get to this point is this. List all the reference angles that you identify. In this particular case, we say, what is the reference angle that would give us a sine output of root 2 over 2, regardless of whether it's positive or negative. And so we say that the reference angle, we list it usually as that angle prime. We sometimes write it as angle party hat. But we'd say in this particular case, we say, what angle could you have taken the sine of to get root 2 over 2? I'm saying that it's a 45-degree angle, or most appropriately, we're supposed to be doing this in radians. So we say a pi-4th radian measurement. So now, before we go and find the actual solution values, what we need to do is we need to go, first of all, ask ourselves, where would this angle have to terminate for our sine value to be negative as it is? Okay. So we notice that the sine value is negative. What this means is our angle could not have terminated in the first or the second quadrant because our sine values would have been positive up there. So now that we've isolated the quadrants for which this angle could have terminated, what we're going to go down here and do is we're going to sketch in these two reference angles where we knew that this reference angle here is a pi-4th radian measurement, and we know that this reference angle here is a pi-4th radian measurement. So the question that we're trying to answer, however, was this. What's the actual angle, or the solution values? Okay, maybe on the interval from 0 to 2 pi first. That means I just want to know what angles between 0 and 2 pi would give us a sine value that comes out to be negative root 2 over 2. And since they both have to have pi-4th radian reference angles here, we say, well, then one angle is this guy right here, and the other angle is this guy right here. Okay. And so knowing what we know about the rotations here, we could say that this is pi, or we're talking about fourths here, we say 4 pi-4ths. So this would be a pi-4th past 4 pi-4ths. So one of our angles in this particular instance is this. 5 pi-4ths is one of our solution values. And then we say, okay, well, this one over here was a pi-4th short of 8 pi-4ths, or a 2 pi rotation. Thinking 2, so I wrote 2, sorry about that. So we'd say that this is a pi-4th short of 8 pi-4ths, so this is 7 pi-4ths. So we have two solution values in this particular instance, 5 pi-4ths and 7 pi-4ths. And then the only other thing we need to do is, if we want all possible solutions, or infinitely many solutions, we need to say, well, not only would we have 5 pi-4ths, but we would have one where we added on another 2 pi spin, or if we added on another 2 pi spin, or another 2 pi spin. So what we're going to do is we're just going to add on multiples of its period. In this particular case, we say the period is 2 pi n. So we say plus 2 pi n. Okay. So these are all possible solutions for this particular equation. Now, what I want to do is actually I want to verify this graphically. So what we started with was y equals, sine x plus root 2 on one side and y equals negative sine x. We're really asking where are these two graphs, or what x values would cause these two y values to be equal. So I'm going to go ahead and pursue this in terms of the fact that we should have set it equal to 0 first. And what we're going to do is we're going to say, take this equation right here that we had set equal to 0 and go graph it. So we have 2 sine x plus the square root of 2. So we'll go ahead and type this in here just to verify this visually. We have 2 sine x plus the square root of 2. And what we want to know is, where does this have an output of 0? So we say that 0 is just the x-axis. We're finding the zeros of this equation. But at least on the interval from 0 to 2 pi, you can see that at 5 pi fourths and 7 pi fourths are these two values, or input values, or angle values, or x values, for which our graph has an output of 0. And so all of these other angles are really just these initial two angles from 0 to 2 pi, where we're just adding on a period length to it, or subtracting off a period length to it, and getting to another spot for which this is a satisfied equation. And then last but not least, we can verify this just by looking at the unit circle. But again, we were asking this question, what are the angles from 0 to 2 pi at least, for which our sine value is negative root 2 over 2? And we can see that negative root 2 over 2 for a sine value occurred at 5 pi fourths, or 225 degrees, and also at 7 pi fourths, or 315 degrees, we had a sine value of negative a half. Okay, so it's easiest to just navigate with reference angles and constructing it as we did here from there. But if you have a unit circle next to you, we can also answer this question pretty easily. Cheers.